Alright, contents. Chapter 3, cables, places, termination, 15 kilovolt underground distribution cable layers. Other example, the cable layering, oil-filled cable, transmission cable, self-contained transmission cable, conductor metal types, conductor composition, conductor shapes, insulation compounds, insulation thickness, sample cable specification, 15 kilovolt XLP, insulated 4-0 American wire gauge aluminum cable with a jacketed concentric neutral. Product test, insulation test, dimensional verification, electrical status, distribution, termination, electrical stress, minimization, live front application, dead front, load break, elbow, termination, detail, inline cable splices, cold shrink splices, temperature correction, table of temperature correction, formula adjustment for other temperatures, sample calculations. Alright, let's move to Chapter 3. Chapter 3, cable splices and terminations. A 15 kilovolt underground distribution cable layer with metal conductor with the inner layer with a cable that carries the current with the conductor, strand shield, the layer with the plywood between the conductor for the insulation, equalize the towers around the conductor that are seeking a less resistive path to the ground, insulation compound with the surround with the conductor, and isolate the metallic conductor from the ground, semiconductor ring applied semiconductor conducting layer applied between insulation of the neutral conductors or outer shield layer, outer layer metallic shield, copper wires for the metallic ribbon shield that provides a ground return for the even short and short circuit occurring during the cable failure. Bending tape layer insulated between the insulation conductor sheath that allow for the expansion within the layers may or may not contain water, swelling, resin, or powers. Outer jacket polyvinyl chloride or polyethanol jacket that seal the cable from the environment. Figure 3.1 show the typical cable with the underground primary distribution aluminum strand conductor with has a semiconductor shooting shell with a cross link with the polyethanol insulation semiconductor extruded insulation shield with surrounded by a spiral wound exposed. Tin copper neutral conductor. The copper neutral conductor is often jacketed with polyethanol. Other example, the cable layering, 321, and then a 654-321. So the cable construction non-shielded the cables. A stranded is in shown figure. Stranded A is stranded shielding. 2 is insulation. 3 is the cable jacket, and then B, your stranded shielding, insulation, semiconductor material, metallic shielding, bending tape, and cable jacket. Oil-filled cable, paving from the right, paving thermal sand, backfilled petroleum oil, shaded skid wires, D-wires, steel, brass, zinc, etc. Moisture seal, conducting wrap, oil impregnated craft wrap, paper wrapping, conductive tape, insulated segmented compressed stranded conductor. And then from the bottom of the left up is the inner protective coating with the quarter-inch steel pipe, coal tar plastic protective coating. Figure 3.3 is a cross-sectional single-circuit oil-filled pipe type cable system. Transmission cables show the standard conductor semiconductor shield, semiconductor dielectrical shield, extruded insulation, helical wounded copper tape, polyethanol jacket. Figure 3.4 construction solid dielectrical extruded insulation high voltage transmission cable. Alright, 64. Page 64. Self-contained transmission cable, oil duct, jacket, sheath, drainage segment, conductor, insulation, cross-sectional view, self-contained cable used for the underground transmission circuits. Conductor metals, aluminum, copper, conductor composition, stranded solid. Show the concentric round, compact sector, angular, and segmental. Diagrams common shape of the stranded conductors, insulation compound, EPR, ethanol. EPR stands for ethanol propylene rubber. XPLE is crosslink polyethanol. TXLPE tree retardant polyethanol. HMWPE high molecular weight polyethanol. PILC paper insulated lead covered. Insulation distribution thickness 5 kilovolts 100% insulation 90 mils, 133 insulation 90 mils, 15 kilovolt 175 mils at 100% insulation level, 133 insulation 220 mils, 25 kilovolt 260 mils, 100% insulation level, 345 133% insulation level, and 35 kilovolts at 345 mils at 100% insulation level, 420 mils at 133 insulation level. 100% level of the ground fault will be cleared within 1 minute. 133% level of faulty clearing requirements will not meet the 1000 or 100% criteria, but fault will clear within 1 hour. Or sample cable specifications: the 15 kilovolt XLP, the insulated 40-0 American wire gauge aluminum cable jacket with a concentric neutral. The specification cover the typical 15 kilovolt with a cross-link polyethanol insulated shield concentric neutral cable with overlapping insulation jacket. Application of this cable is for 60 hertz wide connected system with a ground neutral operating with 13,200 wires connected to 7,620 volts. The cable should be suitable for the insulation and ducts and direct burial within the earth and wet or dry location. The cable should be furnished with a 4-0 American wire gauge 19 strand aluminum conductor. The maximum conductor temperature shall be within 90 degrees Celsius, normally 130 degrees Celsius emergency, and 254 degrees Celsius short circuit. Conductor alloy 1350 aluminum stranding shall be Class B, compressed stranded per ASTM B231. Conductor strand shield layer. The conductor strand shield layer shall be extruded over the stranded conductor with a good concentricity shall be black insulating material compatible with the conductor and primary insulation strand shield layer will have the specific inductive capacity with a kind of greater additional energy suppression function with the layer will be provided with the stress with relief of the interface for the primary insulation stranded shield layer and should be easily removed with the conductor with a usually common available tools should have not the thickness of any other part with less than 12 mils. When measured over the top of the strand, the outer surface of the extruded strand shielded layer shall be cylindrical, smooth, and free of significant irregularities. Primary insulation. The primary insulation shall be 175 mils extruded with a tree retardant with a cross-linked polyethanol compound with the primary insulation should be extruded directly over the conductor strand shield level with a good concentric shall be compatible with the conductor energy suppression layer. The outer surface of the extruded primary insulation shall be cylindrical, smooth, and free of significant irregularities. Insulation shielding system. The cable insulation shielding system shall be considered the semi-conducting extruded strippable cross-linked material. The insulation should be minimum point of the maximum point. Maximum indent thickness shall be 800 thousandths or to 900 thousandths an inch. Alright, concentric neutral. The concentric neutral consist of 16, number 14 bare wire, copper wire for the corners of the NSI B3 with the shall be spirally wound over the insulated chip with a wound uniform space between the layers and layer of not less than 6, not more than 10 miles of the cable diameter. Jacket of the shell should be lined with the low density of the polyethanol extruded over the casseting with the concentric neutral. Minimum average thickness shall be 50 mil. The minimum thickness at any point of the cable shall not be less than 80% of the minimum average. Identification. Outer surface of each of the jacketed cable shall be durably marked with a sharp fit defined with the surface printing. The surface marking shall be as follows: the manufacturer's name, conductor, the material, rated voltage, year of the manufacturer. Symbol for supply cable per NESC C2-350G. Cable diameter dimension control over diameter of the 15 kilovolt for the insulated cable shall not exceed 1.35 inches. Production test. Conductor test. Conductor shall be tested in accordance with the AEIC CS9594 with the ICEA standard S66524. Standard copper strand shielded weather integrity with the conductor strand shield layer will continuously monitored prior to during the extrusion of the primary insulation using the electrode system, completing the covering with the full circumference of energy suppression level layer of the test voltage with the 2 kilovolt direct current insulation test. Primary link tank test. Each individual length of the insulated copper with the conductor prior to the application for the further covering shall be immersed with the water tank with a minimum of the period of 24 hours. At the end of the 16 hours of the minimum, each length of the insulated copper conductor shall be at least DC voltage for the stranded test applied for the 5 minutes. For the applied DC voltage should be 770 kilovolt. At the end of 24 hours minimum, each length of the insulated conductor shall be in path AC voltage withstand. Test applied for 5 minutes. The applied AC voltage should be at 35 kilovolt. Each length of the insulated conductor found the 5-minute AC voltage test shall have an insulation resistance covered at 15.6 Celsius degrees or 60 degrees Fahrenheit, not left of the value with the insulation resistance over the ohms over the merit of the ohms over the 1,000 feet. Calculated with the following formula after electrification for 1 minute. The initial resistance of the mirror of the 1,000 feet is equal to the 21,000 mirror ohms of the 1,000 feet log 10 base times with the diameter over the insulation divided by the conductor diameter. Final test and shipping with each length of the completed cable shall apply the AC voltage withstand the test applied for the 1 minute. With the applied with the AC voltage should be 35 kilovolt each. Length of the completed cable found with the 1 minute with the AC voltage test shall have the insulation resistance not less than specified above. Above the dimension verification, each length of the insulated conductor should be examined to verify that the conductor is the correct size. Each length of the insulated conductor shall be measured to verify that the insulation wall thickness is in the correct dimension. Each length of the completed cable shall be measured to verify the jacket of the wall thickness for the correct dimension. Conductor shield continuity with each length of the completed cable shall be be tested with the conductor shield continuity. Test report, certified test reports of all of the cable will be required. One over the copy with the test reports will be sent with the order of the ordering party. Shipping length will be specified with the inquired with the purchase order. Unless otherwise specified with the purchase order, the cables will be furnished and one continuous reel. Reels should be heavy-duty wooden reel if possible, properly with the inspected clip with ensure that no nails, splinters, etc. may present with the possible damage of the cable. With each end of the cable should be firmly secured with a reel of the non-metallic rope. The wire strain with the non-acceptable for securing cable through the reel. With the deck board with the plywood covering secured with a seal band is required over the cable. Cable sealing. Each end of the cable should be sealed hermetically before the shipment is using either heat shrink polyethylene caps or hand tapping. Whichever the manufacturer recommends, metal claim that may be the damage of the pulling of the equipment are not acceptable, and seal must be adequate to withstand the rigors of the pulling. Preparation of the transit reel for the must be secure blocking in position so that they will not shift during transit. Manufacturer shall assume the responsibility of any of the damage incurred during the transit as the result of the improper preparation of the shipment. Reel marking. Reel marking shall be permanent with the stencil of the one plane with the wooden reel, such for the marking with the shall contain with the purchase or requirements to indicate elsewhere with the specification, but with the consider the minimum with the description of the cable purchaser order, the number, the manufacturer's order number, the date and shipping, the footage of the reel, and the reel number. The arrow indicating the direction of the reel should be rolled with the shown at the end of the sample of the specification. Electrical stress distribution. Show of the ground, the shield of the insulation, the conductor of the K is equal to the dielectrical constant K1 over the insulation and the conductor K2 3.3. Electrical stress distribution, high voltage solid dielectrical insulated shield cable with the shield with the insulation partially removed with the cable, the conductor now high concentration electrical stress for the edge of the cable shield, termination electrical stress and minimization shield, the conductor insulation, electrical stress distribution complete with a completed prefabricated splice insulated with a solid dielectrical insulated shield with high voltage cable stress and transition area from the cable to splice evenly distributed. Show the conductor shield with the insulation. Live from application riser pole and lug terminal for the correct insulation with the terminal vinyl tape mark with the ridge edge of the cable, the shield with the semiconducting, the ridge end of the K tube, semiconducting shield with the cable insulation conductor, hot case truss leaf. Typical termination makeup with a single phase with a 7,620 volt cable with the underground distribution and dead front application load breaking termination with a pulley eye with a male contact with the arc follower with a silicone valve with a conducting shield with a clipper with a grip contactor cable, semicon tape with the semiconducting tape with the insulating tape with the PVC jacket type and the cable conducting sheath. Figure 310 is the cross-sectional view of the load break terminal with the component parts identified. Alright, your dead front load break elbow termination. Concentric neutral mastic first layer, step 1. Step 2, overall jacket the concentric neutral. Insulation, semiconductor material conductor. Step 3, vinyl tape, two half layers with the over mastic, second layer over the concentric compression lug supplied with the elbow cold shrink. Step 4, and also the step 5 of the 2 ground wires cold shrink. These steps involved with the makeup of the cold shrink seal with the dead front termination, each with the proper dimension of the cable and layers installed with the instruction included with the manufacturer elbow insulation kit. Alright, inline cable splice with the cold shrink splices. Over the top one show that's from the top of the right and clockwise. Insulation shield, insulation unique electrode design, silicone body provided with the excellent electrical property of the one-piece design splice body at 100% with the factory tested to ensure long-term reliability. Alright, starting from 12 o'clock in the middle of on the bottom second. Unique design with the electrode minimize the electrical stress. Good seal between the cable and splice. Lower interface electrical stress. Undercut end of the electrode plate piece with a high stripe with the entirely spliced insulation field with a feathered insulation with the beginning of the cone minimize the electrical stress. Figure 312 with the cross-sectional view of the prefabricated cold string splice insulated with a concentric neutral cross-linked polyethanol insulated underground cable. Our cable ampacity table, material application size, aluminum, single phase with application, 3-phase application, triplex arrangement, maximum volt amps and maximum amps. Earth interference temperature on that 60 degrees, normal cable temperature 90 degrees Celsius, emergency cable temperature with 130 degrees ambient earth temperature, 208 degrees Celsius, earth resistive 90 degrees Celsius centimeter over the W, depth of aerial with a 36 degree daily load factor 80%, 3-phase load balance, single phase application full neutral, concentric, 3-phase application reduced neutral, concentric, single control conductor cables with the XLPE, TRXLP EPR insulation. And then it's continued, and it shows the copper single phase, the application, three-phase application, copper tables, ampacity value for the cable temperature is varied. Cable temperature adjusting factor, aluminum set direction, the 4.0 aluminum set direct, 750 aluminum set direct, 750 aluminum set duct. Those are all the amps and change of the percentages. Table 3.3 multiplication factors, aluminum cable temperature, ambient earth temperature are varied with the standard cable temperature at 90 degrees Celsius and ambient earth standard at 20 degrees Celsius. Shows the aluminum cable temperatures in degrees Celsius, ambient temperature for the temperature degrees Celsius, 0, 5, 10, 15, 20, 25, 30. Multiplication factors, copper table, the ambient earth temperatures are varied. Standard cable temperature with the 90 degrees Celsius, ambient earth standard temperature, cable temperature with the copper, 0, 5, 10, 15, 25, 30. Ambient earth temperature, cable temperature. Alright, temperature correction formula, information courtesy of the south wire. Adjustment of the other temperature of the softness and determine the ampacity of the condition of the publisher of any value with the ampacity may be adjusted with the cable with one changing one or more basic parameters with the following equation. Copper introduction is equal to amps amps temperature correction over the temperature ambient over temperature temperature correction of the temperature ambient temperature correction the adjustment amps the prime value of the revised amps, the prime amp value of the amps times the square root of the temperature correction minus the temperature ambient over the temperature correction minus the temperature ambient times 234 times the 234 plus the temperature correction over 234 plus the temperature correction primed, and it gives you the amp. The aluminum conductor said if the amp primed is equal to the amps over the square root of the amp times the square root of the temperature correction minus the temperature ambient, and over the temperature correction minus the temperature ambient times 228 plus the temperature correction over the 228 plus the temperature correction in amps. Sample correction: 90 degrees Celsius rated copper cable to plunge published with the ampacity of the 500 amps. Over the within set with the addition include the ambient temperature at 40 degrees Celsius. Find the ampacity of the temperature at 80 degrees Celsius and the ambient temperature at 50 degrees Celsius. You get the amp primed was equal to 500 over the square root of 80 minus 50 over 90 minus 40 plus times 234 plus 90 over the 234 plus 80. You get 500 times 0.787 and 393 amps. And that was the notes, and that was Chapter 3. Chapter 4, Distribution Voltage Transformer.